This first presentation is talking about the infrastructure, so is talking about fog computing, and I will ask if it's possible to start the video, and let's talk after the end of the video. Thank you.
Good afternoon, everyone. Welcome to the fog computing session. First, let me introduce myself. I'm Gianfranco Silvestri. I'm the Business Development and Innovation Manager from AD Consulting. Today, I'm going to talk about fog computing, and I'll be speaking to you about some applications like connected cars, smart cities, etc. Let me start by giving you some background information about the agenda. We are going to talk about cloud computing limitation, fog versus cloud, fog computing characteristics and technology architectures, and a couple case studies and applications, for example, connected cars, smart city, and healthcare. As you are aware, cloud computing is a type of computing that relies on sharing computing resources rather than having local servers or personal devices to handle applications. But as you can imagine, there are some limits. First of all, it is not always connected. In fact, connectivity to the cloud is a prerequisite of cloud computing. In addition to this, some IoT systems need to work even if connection is temporarily unavailable. Another limit of cloud computing is that it doesn't always have enough bandwidth. The cloud computing supposes that there is enough bandwidth to collect the data, but this assumption becomes overly strong for industrial IoT applications. Another problematic is about the centralization of cloud computing analytics, therefore defining the lower bound reaction time of the system. But in several cases, some IoT application might not be able to wait for the data to get to the cloud, be analyzed, and for insights to get back. Last but not least, another important issue is security shortcomings. Be that data protection mechanism in cloud computing, such as encryption failed, it wasn't able to protect the existing data from hacker attacks. Whereas the cloud is up there in the sky somewhere, distant, remote, and deliberately abstracted. The fog, instead, is close to the ground, right where things are getting done. Fog computing is a paradigm that extends cloud computing and services to the edge of the network. Fog computing places processes and resources at the edge of the cloud, often on network devices, while data remains stored in the cloud. This leads to faster processing times and fewer resources consumed. As you can see in this slide, fog computing has a lot of advantages compared with the cloud computing. In my opinion, latency, distance between the client and the server, geographical distribution, number of the server nodes, and type of last mile connectivity are for sure top priority, especially when we're talking about car connected or smart city. What are the top characteristics of fog computing? Geographical distribution. The services and application objective of the fog are widely distributed. Support for mobility. Fog devices provide mobility techniques like decouple host identity to location identity. Real-time interactions. Fog computing requires real-time interaction for speedy service. Heterogeneity. Fog nodes can be deployed in a wide variety of environments. And last, interoperability. Fog components must be able to interoperate in order to give wide range of services like streaming. Let's talk about the three important pillars of fog computing. The IoT sensors are placed at the bottommost layer of the architecture and distributed geographically. They sense the environment, emitting observer values to upper layers via gateway for further processing and filtering. IoT data streams are made of a sequence of immutable values emitted by sensors. IoT actuators similarly operate at the bottommost layer of the architecture and are responsible for controlling a mechanism or system. Actuators are usually designed to respond to change in environments that are captured by sensors. Fog devices. In the architecture, any element in the network that is capable of hosting application modules is called fog device. These devices that connect the sensors to the internet are generally called gateways. So, what we can see in real life the fog computing application? In this first example, connected car, the fog computer is ideal just because real-time interaction will make communications between cars, access points and traffic lights as safe and efficient as possible. Fog computing will be the best option for all internet-connected vehicles because fog computing gives real-time interaction. And does it work? Yes, it works, and we did it. We did it here in Modena, in MASA, Modena Automotive Smart Area. And what we did, we implemented the real-time reduction of delay times from 3 to 5 seconds to milliseconds, OBU onboard unit support with roadside calculation, communication security from vehicle to fog and from fog to cloud. And by the way, already aggregated data means less cost for connectivity and cloud services. The Internet of Things, IoT, aims to connect billions of smart objects to the Internet, which can bring a promising future to smart cities. These objects are expected to generate large amounts of data and send the data to the cloud for further processing, especially for knowledge discovery, in order that appropriate action can be taken. However, in reality, sensing all possible data items captured by a smart object and then sending the complete captured data to the cloud is less useful. Further, such an approach will also lead to resource wastage. For example, network, storage, etc. The fog computing paradigm has been proposed to counterpart the weakness by pushing processes of knowledge discovery using data analytics to the edges. Let's talk about healthcare. If we take a look today, we will see that healthcare systems in most countries face enormous challenges that will increase due to aging population and the rise of chronic diseases. We also have a growing nursing staff shortage, and much time is wasted in hospitals by manually measuring biometrics parameters and transferring the data between systems. But how can fog computing help us? For example, it can be locations to be more dynamic. New sensors can be added to existing infrastructure, increase the area where patients can be monitored, reduce latency, and improve response time. I would like to thank you for your attention. Feel free to call or to contact me if you need any help, and I wish you a great day. Thank you very much, Gianfranco Silvestri.
Gianfranco already introduced. We are a smart mobility agency. We announced this morning that this agency was created by companies that were part of MASA project from the beginning, in order to create the possibility for companies, different research entities to have an operative reference for services, and to have someone to complete all the requirements, all the needs that can be useful. Today we are going to show you, we are a bit in delay, so we go very quick. We are going to show you some of the sample of what we actually physically do in the areas in Modena and with the collaboration in other towns with different companies, Italian and international. And next one, we move to Aeroautodromo di Modena, one of the funding partners of Smart Mobility Agency. Smart Aeroautodromo di Modena has been opened in 2011 and to cover the needs of technological innovation, and this is part of Motor Valley infrastructure. So it has a dedicated area for smart mobility, just a few kilometers from Modena, and Alberto Nobile is going to show us a bit of its history and its proposal, and also part of the future plans.
Salve, sono Alberto Nobile e mi occupo dell'Autodromo di Modena, in particolare della smart area all'interno della struttura. Oggi voglio raccontarvi del potenziale di un'area del genere in un contesto innovativo come quello della città di Modena. Per farlo partirò lontano nello spazio e nel tempo. Infatti andiamo ai primi del Novecento, quando in Inghilterra, per via di delle particolari restrizioni alla circolazione stradale, parliamo di una mobilità completamente diversa da quella di oggi, si venne a creare l'esigenza di un circuito per le gare automobilistiche. Questo circuito, appunto quello di Brookland, nacque con lo specifico intento di andare a realizzare delle gare, ma fu utilizzato anche per lo sviluppo di velivoli, per cui era il primo vero aeroautodromo, un destino curiosamente condiviso con quello nato quasi 50 anni dopo a Modena, perché appunto l'aeroautodromo di Modena, nato nel cuore della città, al centro, dove oggi sorge un parco, era famoso per il suo aeroporto al centro di questo anello, sul quale si svolgevano delle gare notevoli a livello nazionale. Si parla di gare di un certo prestigio, di piloti di un certo calibro, adesso entrati nel novero dei piloti storici che noi ricordiamo tutti. Ma oltre ai velivoli si sviluppavano in questo circuito anche le auto allora agli albori di una nuova era, auto che nel corso dei decenni successivi divennero e sono oggi eccellenze mondiali riconosciute nel mondo, che nel corso dei decenni hanno costruito una storia. E dove l'hanno costruita questa storia? Sulla via Emilia. Modena nasce nel cuore di quello che è la Motor Valley, una valle veramente sensazionale per presenza motoristica e di realtà piccole e grandi che siano riconosciute a livello mondiale, una via che collega tutta l'Emilia Romagna e che ha in sé tante eccellenze. Tutta questa premessa è doverosa per raccontare appunto come si trasforma un circuito. Il DNA dei circuiti nascono appunto per le gare automobilistiche, ma nascono in un periodo, in una era completamente diversa, fatta da una mobilità diversa e delle esigenze di mobilità completamente diverse. Ma nel momento in cui questa mobilità cambia, come possiamo adeguare una struttura che di per sé nasce in un altro periodo, in un'altra epoca, come possiamo incastrare questa innovazione nella tradizione? È una domanda che ci siamo posti diverse volte, sin dall'inizio, fin tanto che nacque il nuovo Autodromo di Modena, quello che gestiamo oggi, e sono domande che hanno portato ad alcune risposte, come un nuovo modello di business. Fintanto che nel 2011 si creò questa nuova struttura, nata appena fuori Modena, abbiamo ideato un nuovo modello che ci ha consentito di accrescere l'incoming locale, di essere di grande interesse internazionale, perché abbiamo portato il livello esperienziale delle gare a contatto con l'utente appassionato, per cui abbiamo creato veramente un nuovo modello di business che ha portato alla creazione di pacchetti, allo sfruttamento dell'emozione della gara, all'onda lunga dell'emozione della gara, per creare quell'atmosfera che piace tanto agli ospiti che visitano la città di Modena, Maranello, l'Emilia-Romagna in generale, la Motor Valley. E lo abbiamo fatto facendogli guidare delle vetture da gara. Quindi l'emozione che abbiamo creato, l'esperienza che abbiamo voluto trasmettere è quella del pilota da gara. Questo non ha snaturato il DNA dei circuiti, lo ha semplicemente ampliato. Quindi tutto quello che è stato creato nel corso dei decenni, questa grande atmosfera di suspense, lo abbiamo portato alla mercé del cliente per poterlo sfruttare a 360 gradi. Ma ci siamo posti anche altri quesiti nel corso degli anni, per cui dal 2015 abbiamo cominciato a immaginare la nuova mobilità, il futuro, come poteva essere, quindi oltre quello che era il DNA dei circuiti. E lo abbiamo fatto sperimentando per esempio un centro urbano all'interno della struttura. Quindi una mobilità sostenibile, una mobilità diversa, una mobilità innovativa, che guardasse non solo all'elettrico, guardasse al connesso, guardasse alla connettività, alla mobilità autonoma, automatica, tutte le nuove tecnologie. Questo ci ha consentito di continuare a sperimentare, abbiamo veramente dato vita a diverse situazioni in merito, abbiamo creato una piccola autostrada, abbiamo creato degli spazi che non credevamo possibili, però li abbiamo messi in funzione, siamo riusciti a sviluppare degli ADAS all'interno della struttura, una struttura che ad oggi ha un forte limite negli spazi, però li abbiamo creato qualcosa che non esisteva. E per farlo non l'abbiamo fatto da soli, perché siamo stati in gruppo, abbiamo creato un grande team, siamo stati inglobati in un grande team che è quello di MASA, la Modena Automotive Smart Area, che è il fulcro, una punta di diamante di Modena, e che vede protagonisti il Comune di Modena, l'Università di Modena e Reggio Emilia e delle aziende private che hanno creduto sin dall'inizio in questa vision. Questo ha portato all'ulteriore creazione di una nuova struttura, di un nuovo strumento che è la Smart Mobility Agency, fatta da 3 aziende private e che ci ha consentito di acquisire un know-how specifico che abbiamo poi traslato su quello che è il futuro dell'autodromo. Un ampliamento, un potenziamento dell'autodromo che vi mostriamo in anteprima e che prevede una grande parte innovativa nuova per il futuro dell'azienda in una grande smart area. Quindi abbiamo ingrandito quello che abbiamo sperimentato, lo abbiamo portato a livelli estremi per poter competere a livello internazionale. Questo per crescere, quindi abbiamo cominciato a immaginare come crescere. Perché questo? Perché vogliamo che sia un potenziale strumento da utilizzare in maniera molto efficace per la città di Modena, perché ha in sé uno strumento nuovo, innovativo da poter spendere. Modena è una città molto innovativa, e uno strumento nuovo per l'Emilia-Romagna, che ha già dei circuiti storici con delle gare storiche che sono pregni di storia, e Modena si inserisce in un contesto innovativo, quindi qualcosa in più da spendere e da avere di pregio per l'Emilia-Romagna, per la Motor Valley, un nuovo contesto innovativo e soprattutto per l'Italia, che riesce ad avere uno strumento molto efficace da poter proporre anche all'estero. Io vi ringrazio per l'attenzione e buona giornata a tutti.
Thank you, Alberto. Great presentation and fantastic video. Let me just do a little comment about that. In my opinion, the link between developer technology and the human age rings like you, like Autodromo of Modena, is very, very close, because it permits, in a very short time, to test real objects in real life. And by the way, you and your team, Alberto, are a great example. Anyway, let's go forward. Since 25 years, Danisi Engineering support most important automotive brands for car design and production of prototypes and components. With its services of simulators, XLI, professional drivers, and workshop supports MASA project. And by the way, it's a founding partner of Smart Mobility Agency. Marco?
Yes, they are going to show us today what they do with the simulators, rigs with software, hardware, and human in the loop to support the activities and to propose services to support all the development that we can do here at MASA. We can go with the link.
Buongiorno a tutti and welcome to the Danisi Engineering headquarters. Danisi Engineering is a company that was born 25 years ago with specific skills on vehicle dynamics and chassis engineering. Through these 25 years, we were adding a lot of other competencies, methodologies and tools. And nowadays we are a full service supplier that is giving support to OEMs and Tier 1 in developing new products and mainly new vehicles. We put a specific focus on integration, so we were developing a lot of innovative methodologies in order to better integrate the complex system that is a modern vehicle. Here in this facility we have some of the most advanced tools and we will go through these tools. We will present you our methodologies, and to do so I will leave you with Maurizio, that I will join very soon, and we start our tour.
Hi everybody and welcome in Danisi Engineering. In this period, the automotive sector is facing a sort of revolution if we consider the electrification path, the autonomous driving development, and new frontiers in connectivity. The big challenge is to introduce in the market as quick as possible new features and innovative technologies, but keeping in mind the business sustainability. Before to start with the production of a new product, OEMs and Tier 1 have to face a very long validation and testing process, using a lot of prototypes and pre-series cars, tested in very different conditions. Is there a place in which you can have thousands and thousands of prototypes and a plethora of open roads and testing tracks? This place is our Advanced Vehicle Dynamics Center, in which every day we can test different cars with different architectures. We can validate alternative technical solutions. We can judge the performance of different powertrain combinations. So this is our state-of-the-art methodology to support our customers in developing new products.
In the meantime, we have reached our static simulator area. So here we have one of our main tools in the development process, which is, as I said, the static simulator. The main problem to shorten the development time is to start testing and to start the tuning of all the system as early as possible. And one big bottleneck is when the first prototype will be ready. So, with simulation techniques, simulation methodologies, we can start testing actually before that the first prototype will be ready. Here in our static simulator we have actually we can put a car with all the original electric and electronic systems that will be under development, and we can even integrate some important systems, the physical system. So at the end, here we are able to make a kind of testing that is half virtual and half real. So we can integrate parts like the steering rack, and here we have a specific bench for the steering rack that are real components that gets integrated into the virtual prototype. So actually it is a virtual prototype that is bringing around, is making working real parts. In this way, we can start the development process very much in advance. And there are a lot of strong points in this kind of approach. First one, as I said, is timing. We can start earlier and be quicker. Second is the repeatability of the testing conditions, because when you are in the real testing, it can rain, it can be colder, it can be hotter. Here we can do as many times as we like exactly the same test in fully controlled conditions. So it's a kind of laboratory conditions. Another very strong point is that we have full safety. We can even try and experiment something that is very dangerous, and if something goes wrong, obviously in this situation everything is safe, is under control. We are using this a lot to make the so-called fault injection testing, that is when we inject some bug in the software to check how the system will respond. And to do this in real world is quite dangerous. Here we can do it in full safety. Another thing that I like to show you is this one. This one is a small test rig that can put hardware in the loop, so on the virtual prototype, the real camera for the ADAS systems, for lane keeping, for the automated driving. The camera is here and not on the car because on the screen of the simulator we have an image that is made to cheat the human eye. Here the camera is in front of a screen where there will be an image that is the same and synchronized with the simulator that will cheat the camera. But now we can go to see our dynamic simulator, which is even more spectacular than this one, where Maurizio is waiting for us. Let's go.
This is the dynamic simulator, the most advanced tool we have here in Danisi engineering. That is perfect for supporting each step of the technical development of a new product. With this tool you can feel acceleration and deceleration, you can perceive the grip on the road, you can evaluate and judge the powertrain performance of the vehicle. Oh, ciao Giacomo. Ciao Giacomo.
So here we are, and I would like to, I'm interrupting Maurizio, not that polite, but I would like to add a couple of points about simulators in general and dynamic simulators. Simulators in general is something we didn't mention before, is that we have our engineers in the control rooms that can change any parameter more or less in real time. This is very important because you can test two different setups or two different configurations in few seconds, switching from one to the other. Whilst if you are in the real world, if you don't have two prototypes and you have to update the one you have, it can take several hours. The other aspect that is very important is about integration. We were talking a lot about integration. We say that one of the main competencies at Danisi engineering is integration. With this tool, with the dynamic simulator, we can integrate the driver, so the human, together with the vehicle. In the modern vehicles there is a lot that is done by the electronic controls. The electronic controls needs to keep into consideration the driver. So the driver is acting on the car. The driver is acting as a sensor, feeling what is happening. It is acting as an actuator. So one ring of the control chain is the driver. This tool is a tool that allows us to study the control with the full chain, so with the real driver inside. So this is a way to integrate the reality, again, the driver, a real human, in a virtual methodology. To go deeper into this kind of aspects, into these kind of methodologies. We like to introduce Claudio Nicchiarico, who is responsible for Meccanica 42, that is our daughter company that is specifically focused on controls. So thank you for everything from Danisi Engineering. And,
ciao Claudio.
Ciao Claudio. See you.
Hello Giacomo, thank you for your kind introduction and welcome in Meccanica 42. This company was born in 2015 as a spin-off of the University of Florence in close partnership with Danisi Engineering. In this company we mainly focus on development of mechatronic solutions for the automotive industry, and we validate advanced vehicle functions both on road and in a driving simulation environment. This vehicle is a good example of what we do here. It is a fully bi-drive vehicle. Coming from one of our customers, it is a steer-by-wire vehicle, so the steering wheel is not connected with mechanical joints to the front steering wheel. And we are integrating here a brake-by-wire system in which each wheel is actuated by a single actuator. This is to have a good performance on braking. To guarantee a good level of safety, we also installed a fallback unit. So in case of emergency, the fully passive braking system is recovered. And then we have also a feedback unit to provide the correct feeling on the pedal. Since this vehicle is completely drive-by-wire, we can integrate it into a driving simulation environment. This means that a driver can drive this car into a safe environment where he can test all the functionalities of the vehicle and see, for example, if the vehicle keeps being controllable if one of the actuators goes in fault condition. Now I can drop into the car and take a short run into the VDA. I'm starting the simulation. Just a quick run. I'm going to 60 kph. Now starting steering, recovering the trajectory, and going straight and braking. That's it. Thank you for your time, and the connection goes to Modena. Goodbye, thank you.
Welcome to this presentation by Carmenta. My name is Johan Holmqvist. We are very proud to be on board MASA for the second year and excited that it is performed in digital format this year. In this session, we are going to give you a short update on Carmenta as well as insights in cloud-based technology that gives connected and automated vehicles awareness of their surroundings beyond line of sight. Welcome and enjoy. In this presentation, we will cover a few words on Carmenta. We'll give you an understanding of our product, Carmenta Traffic Watch, and in addition, show some interesting live use cases. Finally, there will be a demonstration of the product before we wrap up this 10-minute session. Carmenta is a Swedish software company specializing in technology and products for geospatial data, situation awareness, and command and control. Carmenta was established in 1985 and employs 125 people in 6 offices in 5 countries in Europe. Carmenta have 3 business areas. Carmenta Geospatial Technologies, who develop Carmenta's technology base and market our developer tools. Carmenta Public Safety, who offers fully fledged system to emergency response operators. And Carmenta Automotive, who we represent today, are offering cloud-based technology that gives connected and automated vehicles awareness of the surroundings beyond line of sight. Carmenta Traffic Watch gives connected and automated vehicles the ability to see far beyond their vehicle sensors. The powerful cloud-based product equips each vehicle with complete situation awareness by collecting both dynamic and static data as well as sensor data from the vehicles. It then constantly analyzes the vehicle's physical environment and automatically issues safety instructions to avoid situations or events that may compromise safe or efficient driving. Carmenta have worked together with customers and partners in various projects showcasing capabilities for cloud-based situational awareness for both connected and autonomous vehicles. We will now show you examples of how Carmenta Traffic Watch can support connected safety functions and fleets of automated vehicles. Tests and demonstrations are performed on public roads but also on test tracks. First example from a Drive Sweden project, we showcase multi-brand sharing of hazard lights through Carmenta Traffic Watch connected cloud solution. In this video we see a Volvo car receiving notification that another car from another brand is standing beside the road with hazard lights on. In the EU finance project Nordic Way, Carmenta have together with partner established a CITS service for emergency vehicle warnings, where the warnings are sent to vehicles where the drivers are made aware about the approaching emergency vehicle well in advance before they can hear or see them. This was showcased in Gothenburg during autumn 2019, and as we can see in the movie, the emergency vehicle warnings from Carmenta Traffic Watch are displayed in the test vehicles from both Volvo cars and Volvo trucks. The third showcase is from a test track where a partly autonomous driving car was connected to Carmenta Traffic Watch, mixing real objects with simulated, showing how the car control system gets both decision support, how to adapt speed in the vicinity of an emergency vehicle, and also receives warnings about vulnerable road users and roadworks. The following short film showcases how Carmenta Control Tower supports automated vehicles with situational awareness and how a control tower setup for a fleet of automated transport vehicles could be arranged. Tests and demonstrations are performed on public roads and on test tracks. Carmenta Traffic Watch collects data from many sources to build and maintain a common operational picture. Connected vehicles can be followed in near real time. Specific roads can be supervised and ongoing traffic situations monitored to decide if any action is needed. Carmenta Traffic Watch has many options to visualize ongoing operations, such as using a heat map to highlight vehicle clusters. Connected vehicles that detect hazards can trigger geofences in Carmenta Traffic Watch to warn other vehicles for entering dangerous areas. Dynamic geofences can also be built around moving objects such as emergency vehicles or hazmat transport. Traffic incidents reported from traffic authorities are followed closely in Carmenta Traffic Watch, and a rule engine is used to decide proper actions, such as automatically send an advice to an OEM to disable autonomous driving on the affected road segment or even issue a safe stop. An incident on the road, such as a traffic accident, can allow a manual operator to decide how and when to issue an advice to the OEM when any of their vehicles approaches the accident. Carmenta have worked together with the Italian company and MASA partner Sprinx Technologies to connect their Sprinx traffic system with our Carmenta Traffic Watch platform. This adds very intelligent traffic monitoring system to Carmenta Traffic Watch that automatically detect and report activities in the traffic environment. One example is pedestrians detection that could be used to warn if a person is walking into a dangerous area. This creates an incident in the Sprinx system that may trigger an action in Carmenta Traffic Watch. The integration also allows control over the Sprinx system and traffic cameras from Carmenta Traffic Watch. Live video feed can be activated by the traffic operator for a better understanding of the traffic situation. Thank you for listening. We hope you find the presentation and use cases interesting. If you have any questions or would like to discuss anything with us, please contact us. Now enjoy the rest of the MASA show, and we look forward to see you all again on MASA next year. Thank you. Bye.
Hello, my name's Jonathan. I am the CEO at Univrses. Univrses is a Swedish company based in the centre of Stockholm, and we are experts in 3D computer vision and AI. Univrses does a lot of work with autonomous vehicles, developing perception technologies, perception solutions for autonomous cars, for example. We process data from cameras and other sensors on board autonomous cars to give them perception capability so that they understand where they are in space, where they are relative to their surroundings. We understand what the 3D structure of the world around the vehicle is. And indeed, we understand the semantic nature of that 3D structure. So, is this lump of structure a park bench, in which case it's probably going to stay still? Or is it a dog, in which case that dog might run out in front of the vehicle? And so Univrses processes data from cameras and other sensors to give those vehicles perception capability.
At Univrses, we're experts at three-dimensional computer vision and 3D artificial intelligence.
We've been very successful at attracting the right sort of people. We work on cutting-edge technologies like self-driving cars and mobile robotics. We We are just incredibly excited to be here in the centre of Stockholm together, building an autonomous future.
What we're starting to do now is give any vehicle perception capability. We're starting to put cameras on taxis, buses, garbage trucks, and other vehicles operating in and around the city to give those vehicles perception capability, to turn them into data harvesting agents. And as those vehicles travel around the city, collecting our rubbish or taking us from A to B, the cameras on board of them will pick up data that, using Univrses algorithms, we can extract information to help run the city in a smarter way. So we can start to detect road damage, we can start to detect traffic signs, traffic flows, pedestrian and bicycle flows, and all sorts of other features that are necessary to help running a city in a better way.
Hello everybody, my name is Paola Clerici. I'm the General Manager and CMO of Sprinx. Sprinx is an Italian independent software vendor specialized to design and provide video intelligence software platforms able to analyze the mobility of vehicles and people. Based on the best of breed deep learning technology and on the awarded 3D object tracking technology, our software platform is able to detect anomalous events in the traffic flow and the mobility in general and to collect statistical data. Sprinx has an international reputation on the market. In fact, we have already provided more than 80,000 video channels in 10 years of our life, and we are present in more than 15 countries all around the world thanks to our local distribution partners. Thanks to our internal R&D department with high profile figures in the field of computer vision and artificial intelligence, we are able to provide something really innovative on the market in terms of mobility analysis. We are very proud to be part to the MASA project because we think that when we speak about smart mobility, we don't speak about a specific technology, but we speak about the combination of the best of breed of technologies. In fact, it's the enrichment of the data coming from different technologies and sensors that can make a mobility real smart. We are very happy because in this case we have provided our software platform that is called Traffics AI, based on deep learning technology, that connected to standard CCTV cameras is able to give information about the mobility, immediate information about anomalous situations like wrong-way drivers or unsafe lane change or stopped vehicle or pedestrian in the carriageway. And this information can be sent immediately to third-party systems that could be the software in the control room, whether are the operators, but also to the drivers, thanks to software installed directly in the vehicles. So the drivers can be alerted immediately and we can reduce the risk of accident. But our technology is able not just to give immediate information about the dangerous situation, but we can collect also useful information about the traffic mobility. For example, we can classify the vehicles, we can count the vehicles, we can give also information about the average speed of the vehicles. These information are very important also for the traffic planners because in this way we can understand if too many trucks are passing in the city center, for example, or too close to the schools, and we can define new rules inside and new plans inside the city. Also, the average speed is a useful information in order to understand if it is important to introduce maybe traffic lights or roundabouts. We can give also information about the direction of the vehicles at intersections and roundabouts. Last but not least, we have a new function that is able to give information about the violation of social distancing. As you know, all of us, we are looking forward to coming back to normality, or at least to a new normality. But to do that, everybody has to respect the rules. As we know, not everybody is able to do that. When we are outside, we forget this, and we must find out something that can help us in order to reduce the spreading of COVID-19 and to come back to the lockdown situation. What we have done, our technology, always using standard CCTV cameras already installed maybe for other purposes in the cities, for traffic mobility or for video surveillance, just video surveillance, security and safety, can be used as sensor to detect social distancing violation. We can give this information to third-party systems, or we can also send an audio message in the city alerting the people in order to avoid to go on in this critical and dangerous situation. So we are very proud that with our technology combined to the other technologies that are installed in the MASA, we can really enrich the quality of the mobility and the safety and the security in order to reach a smart mobility world.
As part of the Torino City Love Initiative, Addfor and the local police started a collaboration to help in fighting the COVID pandemic. This collaboration is about using drones to patrol and monitor the city parks. This activity has been developed in collaboration with the Digital Investigation Department of the local police of Turin, and in particular with the collaboration of the Chief Commissioner Gianfranco. My name is Enrico Busto, and I am the founder and Chief Technical Director in Addfor. Our mission is to provide the most advanced artificial intelligence solution for automotive manufacturing, monitoring, and security application. For more information, you can contact me on LinkedIn or by email with the reference you find below.
We have decided to integrate drone patrolling with artificial intelligence and to introduce autonomous drones in the future. This action will strengthen public safety and security within parks, green area, and other urban spaces.
Artificial intelligence analyzing real-time the video streams coming from the drone, performs the analysis and the detection, and saves the data in the database. The data are used immediately to treat the action of the local police and, at the same time, are stored to be used by the city council and the public administration at any level to make informed decisions on how to manage the city. The starting point is the mission planning. In this case, we use DJI drones and we plan the mission with the DJI dedicated software that is called Flight Hub Enterprise. The Flight Hub Enterprise allows the user to stream images and video together with the telemetry data to an external application, and this is exactly what we need to integrate the artificial intelligence systems. Once the mission has been planned, we are ready to fly. ENAC, the Italian Civil Aviation Authority, granted special permit for this activity, allowing drones to fly over the city parks. Over 140 flying missions have been accomplished over the past few weeks, for a total of 48 actual flying hours, mainly on 3 city parks, Colletta, Carrara, and Valentino. Here, we show you the images taken while flying on the Valentino Park, maybe one of the most beautiful in Turin, located around the river Po banks. A total of 1.7 million square meters of park area have been monitored. Artificial intelligence. We use artificial intelligence to analyze the video streams coming from the drones and detect people, vehicles, and any other object when requested. The detection are corrected in perspective, and the position on the ground is calculated. Since the drones are using 4K cameras, we can detect people even from distance and from high altitude. This is particularly important in the COVID phase 2, since the people are allowed to go to the city park for outdoor activities, but the recommended social distancing should be maintained at any time. Those artificial intelligence algorithms calculate the interpersonal distance between people in real time and raise warnings in case the safety measures are violated. The dashboard. All the data are available in real time and can be stored in database to help in making decisions at commission level. But since the data are available in real time, it can be used to trigger immediate police response. Like in this case, where 2 cyclists were caught in a city park during the lockdown. 3D mapping. Furthermore, the data collected can be used for alternative purposes, however, great importance for the municipality. For example, drone video streams can be used to create high-definition 3D maps of the area overflown, like in this case.
The aim of computer vision is to simulate the functionality of human eyes and brain components responsible for the sense of sight. Doing actions such as recognizing an animal, describing a view, or distinguishing among visible objects in an image or also in the real world are intuitive tasks for humans, and for this reason we fail to appreciate the key challenges that are involved when we try to design systems similar to our eyes. We unconsciously detect objects, and so it is difficult to understand the entire process to train a neural network. To train a neural network, a very large amount of images with the relative ground truth is necessary. And producing this ground truth means facing with the process of assigning a label to each element of the image, or even to each single pixel if we are training a neural network for semantic segmentation. So all images of the dataset, of the training dataset, have to be manually processed, and humans have to draw or at least verify and correct labels or segmentation masks. And this is an extremely expensive and time-consuming process, and commonly it is considered to be not worth the effort. Moreover, the requirement of obtaining a neural network that is able to recognize entities in real conditions, so for example in different weather conditions, different lighting conditions, or an environment that can be various with different characteristics, makes mandatory the heterogeneity and the variability of the training set of images. And this means that if we want to obtain a suitable dataset, we have to collect many images with a large number of characteristics, weather conditions, lighting conditions, and so on. And capturing enough images in the real world and then labeling them, it is an extremely expensive and time-consuming process. So synthetic data can be an alternative solution to replace or integrate real data, and can reduce the problems of cost and waste of time. Obviously, other problems arise, and the most relevant concerns the problem of domain transfer. This means that the synthetic images do not look exactly like real images, even if the larger part of the literature reports that the synthetic images should be as photorealistic as possible. In this sense, laser scan can be employed to acquire portions of the real world, producing 3D environments that have a high level of realism. And these environments can be used to generate synthetic datasets that are suitable to train neural networks. We used a laser scan platform to acquire some areas of the city of Modena. The use platform is equipped with several laser scanners and with a set of 6 cameras. The point cloud was used to model the meshes of the objects in the synthetic scenario and all the geometries in the environment. The images have been used to generate the textures and then the materials of the 3D objects. This technique ensures high level of photorealism, and the 3D environment can be used to exploit all the advantages of working with the synthetic navigable space. It is possible to automatically obtain the ground truth of the rendered frames by replacing the realistic material with monochromatic materials, and it is also possible to change weather and light conditions, or to add specific elements to better characterize the situation, or to represent critical situations such as a pedestrian or a generic obstacle in the car trajectory. Moreover, it is also possible to add a number of virtual cameras and to change many times the point of view.
This concludes our presentation. Thank you very much for your attention, and don't forget to contact us if you need more information. Thank
you. We use infrared cameras, and we detect the features of the face, like the salient features, which is eyes and eye corners and nostrils and mouth and so on. And we build a three-dimensional model of the face using AI that we can track over time. And that can be used to see if a driver in the car is drowsy or inattentive or some other dangerous behavior. And we can warn the driver before the driver actually falls asleep, because of course anyone can see if an eyelid is closed or not. That's usually way too late. You should really give feedback to the driver before that happens. A lot of the algorithms we are using are based on deep learning, so it's completely AI based, but we also have we've been doing this for a long time, so we also have a set of algorithms which works really well, which is just computer vision based traditional algorithms. So one of the strong points for us is that we can use the best from both worlds here. The computer vision algorithms can be very resource light, and the deep learning algorithms can be very robust. So we can use both types of algorithms to get a good, really robust system. That's needed. If this is going to work in the car, it needs to be super robust for sure. This gives the possibility for car makers, even if when they have a level 2 system, which is just partly autonomous, it gives the possibility for the car makers to allow the driver to not keep their hands on the wheel as long as they're really focused on the road. And the trend that we see right now is that the rollout of autonomous technology takes longer time than maybe what people thought 2 or 3 years ago. So we see that for sure there will be level 5 cars in the end, and I mean complete robotaxis that just circulate and you just book them with an app and you just pick you up and you go anywhere. But this is not going to happen like tomorrow or in 5 years. You will have a few level 5 cars, I think, on the roads in 5 years' time, but I think the major rollout is after that. And in the meantime, we see a strong trend where the level 2, 3 and 4 cars are going to get better and better, and they're also going to be supported by driver monitoring systems.
Hi, my name is Peter Rundberg. I'm going to show you what we've been showing here at CES 2020 here in Las Vegas. And first I'm going to show you our state-of-the-art driver monitoring system. So up here in the left part of the screen you can see what a driver monitoring system does. So here we are tracking the head position, the head rotation, the gaze direction, and the eyelid movements and mouth movements and so on of a driver in a car. And as you can see with the overlay graphics on the screen here, that it's accurately tracking me regardless how I move and what I do in the car. On top of all these signals, we are then building state-of-the-art drowsiness detection algorithms and driver inattention detection algorithms and so on that can be used to improve the safety of both a manual and an autonomous driving car. What we're also showing, in addition to our driver monitoring functionality, is our future functionality in the interior sensing space. Over here I'm going to show you how we can combine interior sensing with driver monitoring. In the top right corner of the screen you see a driver monitoring view. You have super high accuracy on my head position and my gaze direction. You can also see in the top left part of the screen that the system has identified me as Peter, which is of course my name, so the system can know and do facial recognition to see who is driving the car. In the main part of the screen here, we're showing body position, how you're sitting in the car, what you're doing with your limbs. We're also tracking objects like cups and food, and also, of course, the main thing in the automotive space, whether or not you are on your phone when you're driving. Now I'm going to go through some of the advantages that you get when you combine driver monitoring with interior sensing. Here in our driving simulator, I'm going to show you the different signals that we can get from the different cameras in the car. So for instance, from the interior sensing system, we can see in the top right part of the screen that I don't have my seatbelt on. So if I take my seatbelt and put my seatbelt across my chest, then it detects that I have a seatbelt, and let me get that in the buckle there. And now I'm safely strapped into the car. It can also detect whether or not I'm sitting in a good position. If I lean out of position, you can see that the car can see that I'm not sitting in a good way and that it might not want to fire the airbag because I'm too close to the steering wheel. You can also see that when I hold my hands out and touch the steering wheel, it detects that I'm holding my hands on the steering wheel, and when I take my hands away from the steering wheel, it can tell that as well. Also, if I take an object and I bring it up to my mouth, like I'm eating, or a cup, I'm drinking, you can see that the system can accurately tell whether or not I'm doing things that could be considered dangerous in a driving scenario. We also do object detection in the rear seat of this car. As you can see now, we have a dog and a child in the child seat in this car. And if we remove the dog from the rear seat, you can also tell that the system then can detect that the dog is no longer in the car. And if we put the dog back, the dog appears again. If we remove the child from the child seat, then the system will detect that there's no longer a child in the child seat, but the child seat is still being detected. And then we put the child back, and the car now knows that we have both a dog and a child in the rear seat. So now that I get out of the car, I unbuckle my seatbelt and I step out, the car will realize that the driver has left the car, and then it will indicate to the driver by sending perhaps a text message or by some audible alert that there's a child and a dog that's been left in the car.
Hi, and welcome to this presentation of Autonoma AI. My name is Anton Kluk, and I'm a data scientist for Autonoma AI. Autonoma AI was founded in 2018 with research funding and close ties to Chalmers University in Gothenburg, Sweden. Our goal is to provide the best AI training data currently focusing on autonomous driving. We achieve this by providing a full solution with generation of worlds and assets, a simulator that supports most sensors, and ML-based post-processing. Our services can be offered as a full package or independently integrated into your existing simulator pipeline. Our goal is not to replace your existing pipeline, but to empower it. To show you what we mean, we have prepared this video. Enjoy.
The University of Modena and Reggio Emilia strongly promotes the learning by doing project. In fact, the so-called secondary skills, as much seek in industry, are very important. Team working, staying on the trail, focusing on goals, task organization. By putting theories into practice, the students learn about up-to-date technologies, thanks to the support from our international technical partners. In UniMoRe we have 4 teams: Formula, Student Combustion, Hybrid, Driverless and Moto Student. The participation to any of the teams can be included in the education program. This demo for the Motor Valley Fest will present the Formula Student Driverless team.
With this project, the students are creating the cars of tomorrow. These cars will really be computer on wheels, with a lot more and more intelligence on board, and they will also be connected cars with the cities, surrounding environment and city via 4G, via 5G and communication and several communication protocols. Developing such systems requires skills of mechanics, of informatics, of telecommunication, of electronics, mathematics and several sciences. And we believe this really makes the difference for students' education, because they are forced to speak the language of other sciences than the ones they studied. Mathematics have to speak with the mechanical engineers, which in turn have to speak with informatics, they have to speak with the telecommunication and electronical engineers.
The Formula Student project consists in the design, construction and setup of an open-wheel car to compete in a series of events organized by the major international engineering association. Each team is only composed of university students, which work independently in a coordinated manner in order to create a competitive car. In Formula Student Driverless, students must build a car that can be either driven by a pilot or to move completely autonomously thanks to radar, camera, onboard intelligence, car control and actuation system. In addition to the car, each team must present business plan and documents that justify all the design choices and characterize it as a real company. Our team is composed by 4 divisions: mechanics, IT, electronics and business. The added value of the activity is that each division is closely connected to the other. This allows you not to focus your knowledge to a sectoral context, but to acquire experience and skills transversely.
The main actuation in self-driving car are brakes and steering, and because we chose the extra challenge on working with the combustion engine, we had to develop a clutch autonomous system. During the development of each actuation, we encountered many problems and adversity due to the fact that the technology often used in these fields are new and in development. An example of this struggle was the braking system. Because of the size and the weight of the vehicle, most common solutions that are available aren't suitable for us. So we had to take a different approach to the matter and come up with a new system ourselves to deliver the performance needed.
With the development of a driverless car, the vehicle's electronics got a totally new role compared to what used to be in the past. Inside the vehicle we added 2 microcontrollers programmed by our team, an ECU and some devices which help us in the development and management of some actuators. One of our tasks is to fulfill all the requests that we receive from the autonomous driving software. In order to achieve that, we are currently working on some models such as an adaptive cruise control, braking system, engine response time, launch control and a robotized gearbox.
As information technology student, we are developing the entire driverless software system, which will be our car brains. Through the camera and the LiDAR, the car is able to scan the circuit, detect the cones and navigate between them. All the data coming from this sensor are processed by a special NVIDIA-powered computers. Neural networks and real-time algorithms do the entire job. To speed up software developing and testing, a custom simulator is being created by us. It is strictly interconnected with our self-driving software, giving us the possibility to try different solutions and tuning parameters with precision without having the necessity to operate on the real car.